Hey everyone, so now that we feel comfortable graphing lines, we're going to be taking a look at graphing systems of equations where we're graphing either two or more lines on the same graph, but today we're only going to be focusing on two at the same time. Okay, so just to review, systems of linear equations. The solution of a system of linear equations is an ordered pair that solves both of the linear equations. It is where the lines intersect on the graph. So here we have this blue line, and here we have this red line, and where they intersect right here at the point 3, 1, that's the point of intersection, also called the solution. So if we were to take this x value and this y value and plug it into both of these equations, it would give us an equation that is true. Okay, but when we're graphing it, we really only need to focus on the fact that that's where they intersect. Let's take a look at the different scenarios that we can see. Okay, this should also be review, but here we can see that we have two lines. They intersect at this one red point, so that means that there is one solution here. So when the lines intersect, there is only one solution. So there's only going to be one point that they intersect. They're never going to intersect again after this point. For this middle scenario, you can see that the lines are never intersecting. These are parallel lines. So if they never intersect, that means there's never going to be a solution. So when the lines are parallel, there is no solution. And here I want you to envision two lines graphed on top of each other. And you can see that they have the same points, so red point, red point, red point, and that's going to continue as long as these lines continue, which is going to be forever because we have these arrows at the end. So when we have two lines that are the same and they constantly intersect, that means that there's infinite solutions. Okay, so when the lines are equal, there are infinite solutions. So one solution, no solution, or infinite solution. There should never be two solutions, three solutions. These are the three scenarios that we're going to have as long as we're dealing with just two linear equations. Okay, so let's practice. So here we're graphing systems of equations to find a solution. It says solve the following system of equations graphically on the set of axes below. We have y equals negative 1/3 x plus 3 and y equals 4/3 x minus 2. So here are our steps. The first thing we want to do is graph the first equation using the slope and y-intercept. So do one equation at a time. So let's focus on this equation here. So I'm going to do this in red. So our slope is negative 1/3, and it's already a fraction, so we don't have to do anything there. And our y-intercept is positive 3. So I'm going to graph this line in red. So remember, when we're graphing, we always start with our y-intercept, which is where y is going to be equal to 3. And then our slope is negative 1/3, so that means we're going to go down 1 to the right 3. And I'm going to continue that. Okay, so down 1 to the right, 1, 2, 3. Down 1 to the right, 1, 2, 3. And I'm going to just continue that as long as I can go. And then I'm also going to put points on the other side. I'm going to do the opposite. I'm going to go up 1 and to the right 3. So basically it's so the pattern can continue, and I want to make my line as accurate as I possibly can. I know on Delta Math you don't have to really deal with this, but if you were graphing this on paper, this is what we want to see. Okay, so now I'm going to connect these as straight as I can go, and I have my arrows. Okay, so that was the first step, graph the first equation. Second one is graph the second equation using that same method. We're going to use the slope and the y-intercept. So our slope is 4/3, and our y-intercept is negative 2. You're going to start with your y-intercept, so I'm going to put a point where y is equal to negative 2. And then our slope is a positive 4/3, so that means we're going to go up 4/3. So I'm going to count. Remember, I'm counting spaces. So 1, 2, 3, 4. 1, 2, 3. So I went up 4 to the right 3. Remember, it's always to the right. And I'm going to continue that. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. I'm going to go in the opposite direction. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Remember, we want this to be as accurate as possible. Connect this. Okay. Now the third step is circle the point where they intersect. This is the solution. So hopefully you notice that they both intersect at this point right here. And that is the point 3, 2. I'm going to rewrite that so you can see it clearly. 3, 2. That is the point that if we were to plug both of these into these equations, it would be true. It's where they intersect. So graph the first line, then graph the second line, and then see where they intersect. That is your point. Remember, we always write x, y, so it's always your x value. So don't make the mistake and write 2, 3. It's 3, 2. Okay, let's take a look at one more example. Okay, solve the following system of equations graphically on the set of axes. It should say to the right. So same thing here. We're going to graph our first line, then graph our second line. Okay, so I'm going to just rewrite these actually because I want to be able to identify the slope and the y-intercept and write it right underneath it. So we have y equals -1/2 x minus 1, and then y equals x minus 4. So our slope for this line is -1/2, and then our y-intercept here is -1. So I'm going to graph this line first. So I'm going to go to where y is -1, put a point right there, and then the slope is negative, so we're going down 1 to the right 2. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And the more you practice this, the better you're going to get at it. Might be a little overwhelming at first, but once you know the process and you know the steps, it gets pretty easy the more you practice it. So make sure you're completing your assignments and practicing it as you should be. Okay. So now I have as many points as I could possibly draw. Tried to make that as straight as possible. Okay. Now let's do the next one. So we don't have a number in front of x. Remember, that means there's an invisible 1 there. So our slope is 1, and we want to write that as a fraction. So I'm going to write 1 over 1. Let me just make this look a little less. Okay. And then our y-intercept is -4. So we're going to put a point where y is -4. And this is a positive 1 over 1, so that means we're going to go up 1 over 1. To the right, always to the right. Up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to just continue that. Now it might seem tedious. Luckily, Delta Math does all of this work for you. Okay, but I want to make sure, especially when we are graphing inequalities, it's so important that you go the entire length of the graph. Okay, so now I'm going to connect these. And I'm going to put a circle where they intersect, which is right here. And that is the point 2, -2. 2, -2. Remember, x, y. Okay, so graph the first line using slope and y-intercept, graph the second line using the slope and the y-intercept, and wherever they intersect, that is going to be your solution.